Late August, 1944. A pale sun rose over the French coast, its light glinting off twisted wrecks and the gray barrels of anti-aircraft guns. In a command post hidden inside a grand old chateau, German officers huddled around a report they couldn't comprehend. The paper trembled in one man's hand, not from fear, but disbelief. 82% destroyed. 82. The figures made no sense. According to every calculation, every rule of physics, every page of ballistic science, what they were reading was impossible. Germany's most terrifying weapon, the V-1 flying bomb, was being wiped from the skies before it could even cross the English Channel. And not by Allied fighters or barrage balloons, but by something else. Something unseen, unknown, and far more precise than anything the Germans believed could exist. What they were witnessing would become one of the most shocking technological moments of the entire war, because at that exact moment, the Allies were using a secret weapon so advanced it was guarded under the same level of secrecy as the atomic bomb itself. The proximity fuse, a small fragile electronic brain that could think for itself, and it was destroying Hitler's vengeance weapons with machine-like perfection. Before we uncover how this tiny invention saved London and changed warfare forever, take one quick second, hit that subscribe button, and join our growing community of history lovers who live for stories like this. Tell us in the comments where you're watching from. We love seeing our viewers from every corner of the world, because this story, this one, will blow your mind. Now let's go back to the beginning, to the moment Hitler unleashed his vengeance weapon 1, and how the invisible miracle that stopped it was born. It was June 13, 1944, exactly 1 week after D-Day. Europe was still on fire. Allied troops were clawing their way inland from the beaches of Normandy when, at 4:25 a.m., the first V-1 flying bomb roared over the English Channel and slammed into London. The explosion ripped through Grove Road in Bow, killing 6 people, injuring 30, and leaving hundreds homeless. To most Londoners, it was just another bomb, another tragedy in a war full of them. But this one was different. It had no pilot, no cockpit, no warning. It was the world's first cruise missile. Powered by a pulsing Argus S-109-014 jet engine, the V-1 carried over 1,800 pounds of explosive, cruising at nearly 640 kilometers per hour. It was fast, mechanical, and terrifyingly simple. To the German High Command, it was the ultimate revenge weapon. Vergeltungswaffe 1, the weapon of retribution. A cheap, mass-producible missile that could be launched by the thousands. Each one cost only a fraction of a bomber and risked no pilot's life. If enough were launched, London would fall to its knees. Major General Walter Dornberger, the architect of Germany's rocket program, believed even a modest success rate, 25%, would inflict more destruction than the entire Blitz of 1940 and 1941 combined. At Peenemünde, where Germany's brightest engineers had already created the V-2 rocket and the world's first operational jet aircraft, confidence was absolute. Dr. Robert Lusser, who designed the V-1's guidance system, ran his numbers again and again. He told his superiors that interception was practically impossible. To destroy a V-1, Allied fighters would have to chase it down, line up behind it at over 650 kilometers per hour, and get within 200 meters before firing. A suicidal task given the V-1's explosive payload. As for anti-aircraft guns, Lusser's calculations were cruelly clear. The chance of a direct hit was less than 1 in 10,000. The math was perfect. The science was sound. And yet within weeks of the first launch, the impossible started to happen. At first, German officers dismissed the reports. Yes, British gunners were adapting, but that was expected. After all, war was evolution. They thought the rising interception rates were temporary. But by July 1944, those numbers had exploded. 17% destroyed, then 24%, then 50%. By late August, 82%. Something unnatural was happening in the skies over Britain. At observation posts along the French coast, German spotters watched V-1s vanish mid-air and clean. Bursts of light, not explosions from direct hits, but eerie detonations close enough to shatter the missiles in flight. It was as if the shells knew where the target was. They didn't know it yet, but they were witnessing the work of one of the most revolutionary devices in history, a secret kept so tightly that even British soldiers firing the guns didn't know what made them so deadly. The proximity fuse, a tiny electronic sensor built inside a shell that could detect when it was near its target and detonate itself automatically. In an age when computers filled entire rooms and radios were delicate furniture pieces, this was science fiction. To the Germans it was impossible, to the Allies it was salvation. But let's rewind a little, because this miracle didn't appear overnight. Its origins go back to an unlikely place, a quiet laboratory in the United States. In 1940, a small group of American physicists led by Dr. Merle Tuve at Johns Hopkins University began working on an idea that seemed ridiculous even to their own military advisors. Could you make a shell smart enough to know when it was close to its target? To succeed, the device would have to survive 20,000 times the force of gravity when fired from a gun barrel. Its vacuum tubes would have to endure temperatures and spin rates that shattered glass and melted solder. Its batteries would need to sleep for years and then wake instantly when fired. The Germans had tried and failed. Over 30 different proximity fuse designs had been researched across the Reich. All of them broke apart before leaving the barrel. So when word of American experiments reached German intelligence, they laughed it off. The proximity fuse was a myth, another Allied bluff. They couldn't have been more wrong. By 1943, while the Axis dismissed the idea as fantasy, American factories were quietly producing 40,000 working fuses a day. Each one was a tiny masterpiece of electronics, a miniature radio transmitter built into the nose of a shell. When fired, it sent out continuous signals. If those signals bounced back stronger, meaning the shell was close to a target, the circuit would instantly trigger detonation. It turned near misses into kills. It turned probability into precision, and it would soon turn Hitler's most terrifying weapon into a complete failure. Meanwhile, back in Europe, Hitler's scientists continued launching V1 after V1 toward England, convinced that numbers alone would overwhelm the British. Between June and August 1944, over 9,500 V1s were fired from launch ramps in northern France. Thousands more were prepared for other targets, but the statistics were merciless. The more they launched, the more they lost. At German headquarters, frustration turned to suspicion. Some believed sabotage was at play. Others thought the British had invented new types of radar-controlled guns. Inspections were ordered, missiles were tested, but everything worked perfectly in Germany. Only over Britain did they fail. They didn't realize it wasn't the V1s that were defective. It was their understanding of reality. Every time a flying bomb approached the English coast, it entered an invisible trap. The Royal Artillery's guns were now paired with American SCR-584 radar, a tracking system so precise it could follow a missile-sized target automatically. Data from the radar fed into mechanical fire control computers, which aimed the guns automatically. And when those guns fired, each shell carried the Allies' most closely guarded secret, a fuse that could see. The result? Miss after miss turned into direct destruction. The V1s never stood a chance, but secrecy came at a price. Even most British gunners didn't know how their shells worked. The ammunition was delivered under armed guard, labeled only with vague serial codes. Each round was accounted for. If a shell misfired or didn't explode, special recovery teams were dispatched immediately to prevent any chance of German recovery. So absolute was the secrecy that even Allied ground troops were forbidden from using the technology until late 1944, months after it had already proven decisive in defending London. Thousands of soldiers would die waiting for the chance to use it. But when it came to saving London, the gamble was justified. Without the proximity fuse, the British gun belt along the southern coast would have failed. With it, the city was saved. By the last week of August 1944, Germany's proudest engineers, the same men who built rockets, jets, and ballistic missiles, were forced to face an unthinkable reality. They were being defeated not by superior pilots or better guns, but by invisible electronics mass-produced in American factories. Factories filled not with soldiers, but with ordinary men and women, thousands of them, assembling delicate components they didn't even understand, trusting that whatever they built would help end the war, and it did. The miracle shells were annihilating V-1s at a rate of more than 80%. The Luftwaffe's proud vengeance weapon had become a death sentence for its own engineers. What began as Hitler's secret weapon had turned into Germany's worst nightmare. But by the middle of July 1944, something extraordinary was happening in the skies over Britain. German engineers, staring through their binoculars from the coast of France, watched the V-1 flying bombs fall from the sky in flames. But what terrified them wasn't that they were being shot down, it was how. Through their telescopes they could see the shells bursting not directly on target but nearby, close enough that the flying bombs simply disintegrated. The explosions were too precise to be random, too perfect to be human. For weeks, reports piled up on the desk of Colonel Max Wachtel, commander of Flak Regiment 155W, the German unit overseeing the V-1 offensive. Every new sheet of data seemed more impossible than the last. 82% interception. German physics said that was absurd. Wachtel's staff rechecked their math. They recalibrated their instruments. They even accused their own observers of error. Yet day after day the same pattern repeated. The British were achieving a level of accuracy no army in history had ever reached. At first, the Germans thought it must be radar-guided artillery. Perhaps the British had developed some new unseen tracking system. But the distances, timing, and precision simply didn't fit. They didn't know it yet. But they were watching a weapon that seemed to think for itself. The mud proximity fuse, or VT fuse as the Allies codenamed it, was unlike anything the world had seen. It wasn't about power or size. It was about timing. Inside the nose of each shell was a miniature radio transmitter, no larger than a child's toy, built to survive the shock of being fired from a gun. When launched, it sent out a constant stream of radio waves. Those waves bounced off anything nearby, an airplane, a bomb, a piece of metal. The moment the returning signal grew stronger, meaning the shell was within a few meters of the target, the fuse detonated automatically. To understand how revolutionary that was, you have to remember what came before it. For centuries, artillery relied on luck and math. You aimed, you guessed, and you hoped. Time fuses had to be set by hand, their success depending entirely on how well a gunner predicted the target's distance and speed. Against fast-moving aircraft, the odds were almost zero. But with the proximity fuse, the sky itself became intelligent. Every shell became its own hunter, seeking, sensing, and striking without human command. To German scientists, this was sorcery. To the Allies, it was science done right, the kind that turns the impossible into routine. What made the fuse's success even more astonishing was how it was built. Germany had the brains, some of the finest physicists and engineers in the world, but not the system to make miracles in bulk. The United States did. By early 1944, the entire American electronics industry had been quietly restructured for one purpose: building proximity fuses. At its peak, the U.S. was producing 40,000 fuses every single day. Factories that once made radios, refrigerators, and hearing aids were now producing precision components for shells. Crosley Corporation, once famous for home appliances, transformed into a military powerhouse, employing over 10,000 workers and manufacturing 16,000 fuses daily. Sylvania Electric, another civilian company, went further. It repurposed its vacuum tube research department entirely to produce the world's smallest, most durable electronic tubes, 400,000 of them every day. Each fuse had to endure forces of over 20,000 times gravity, spinning 25,000 revolutions per minute, withstanding brutal temperatures and vibrations. And it had to do all this perfectly, because even one failure could mean a dead crew or a missed shot. To ensure quality, every fuse was tested multiple times. Random samples were actually fired from guns in test ranges. The rejection rate? Less than 2%. That wasn't just good engineering. That was a new standard for human achievement. By comparison, Germany's so-called vengeance weapons looked clumsy. Each V1 was built by slave laborers in underground tunnels, using materials scavenged from a collapsing war economy. Every part had to be assembled by hand. Every engine was unreliable. Where America had organized precision mass production, Germany relied on painstaking craftsmanship under fear. It wasn't just a moral difference, and it was technological destiny. In August 1944, while Germany struggled to produce 100 V1s a day, American factories were turning out more proximity fuses in a single afternoon than the Reich made V1s in a week, and those tiny devices, on costing as little as $18 each by the war's end, were destroying weapons that cost millions to develop. The numbers told a brutal truth. Germany had lost not just the air war, but the industrial war. Back in occupied France, German intelligence tried everything to understand what was happening. Teams examined the wreckage of destroyed V1s, hoping to find evidence of new Allied guns or radar systems. But the fragments told them nothing. The explosions happened too far away for shrapnel to reach the bomb directly, and there were no recovered shells, and they all detonated mid-air. In frustration, the German High Command ordered test launches over their own territory, away from Allied defenses. The missiles performed perfectly. Every control surface responded, every engine fired. So why did they fail only over Britain? The answer was orbiting invisibly around every V1, an unseen field of radar pulses and invisible intelligence waiting to strike. Still, the Germans refused to believe it. Their scientists declared proximity fuses physically impossible. Miniaturizing a radio that could survive the shock of a gun's firing was beyond their reach. Their vacuum tubes shattered. Their batteries leaked. Their circuits broke apart under acceleration. To them, this kind of technology belonged to science fiction, not to real warfare, but the Americans had done it. Quietly, methodically, and at a scale the world had never imagined possible. By the last week of August, the coastal gun belt around London had become the deadliest air defense network in human history. British crews operated massive 3.7-inch anti-aircraft guns, guided by American SCR-584 radar and powered by those mysterious VT fuses, variable time, as the official paperwork said. The name itself was a deliberate lie chosen to hide the truth. Even the gunners didn't know. They just knew their shells were finally working. Each battery was surrounded by secrecy. Ammunition was tracked to the last round. If a shell failed to explode, recovery teams raced to find it before anyone else could. Every dud was treated like a live atomic device, too dangerous to lose, too precious to risk falling into enemy hands. And so the secret held. The Germans never captured a single working proximity fuse throughout the entire V1 campaign. Not one. Even in December 1944, during the Battle of the Bulge, when German troops captured an Allied ammunition dump containing VT shells, they didn't recognize what they were. They thought they were standard timed fuses. They had no idea that the tiny glass tubes inside those shells could have changed their entire understanding of war. The difference between the two sides was more than scientific. It was philosophical. Germany built wonder weapons, massive, complex, and rare. America built practical miracles and small, simple, and endless. The proximity fuse was a symbol of that difference. For every German weapon crafted like a piece of art, America produced thousands of identical, reliable tools that worked every time. One American scientist later said, "Germany made perfect weapons. We made weapons that made victory inevitable." And he was right. When the V1 campaign began in June 1944, only 17% of the bombs were shot down. By July, that number rose to 40. By the final week of August, it hit 82%. In 10 weeks, the kill rate had quadrupled, not because of better aim, but because of better science. Before the proximity fuse, British gunners needed to fire 2,500 shells to destroy a single V1. After its introduction, they needed only about 100 each week. Thousands of tons of steel and explosives were saved. Each week, thousands of civilians lived who would have died. The British called it the miracle of the gun belt. To the Germans, it was a nightmare without explanation. Inside the chateau where Colonel Wachtel's staff worked, the atmosphere grew desperate. He ordered his technicians to test every component of the V1 system: fuel mix, pulse jet stability, altitude control, even the warhead detonator, anything that might explain the losses, but the results always came back the same: perfect function. Some whispered that the British were using radio waves to jam the missiles mid-air. Others blamed sabotage by forced laborers. A few quietly wondered if the enemy had built thinking shells, but such ideas were dismissed as fantasy. By September, the truth no longer mattered. The V1 campaign had failed. Out of 9,521 missiles launched toward England, only 2,515 reached London. The rest were obliterated in the sky. London still suffered. Over 6,000 people killed, nearly 18,000 injured. But that toll was only a shadow of what might have been. Without the proximity fuse, military analysts later estimated the casualties would have been 4 or 5 times higher. The device had saved an entire city, and perhaps the entire Allied invasion. Because had London fallen into chaos during the Normandy campaign, the tide of war might have shifted. Instead, thanks to those tiny invisible circuits, the city stood. Across the Atlantic, few of the people who built the fuses even knew what they were making. In Sylvania's Ipswich facility, more than 5,000 women worked 12-hour shifts assembling delicate glass components by hand. They weren't told their purpose, only that it was vital. Many discovered, after the war, that the parts they made had saved thousands of lives and helped end the war sooner. Some cried when they learned the truth. It was a victory built not by soldiers alone, but by engineers, scientists, and factory workers who believed that doing their job well could save the world. In the end, that's what made the proximity fuse such a defining moment in human history. It wasn't just a weapon. It was a symbol. Proof that science and production could outmatch ideology and fear. While Nazi Germany chased dreams of perfect weapons, rockets, jets and missiles that dazzled but failed, the Allies poured their strength into systems that multiplied human effort 1,000 times over. The proximity fuse didn't just shoot down V1s, it changed warfare forever. It proved that the age of guessing was over, and the age of intelligent machines had begun. By the final weeks of August 1944, deep inside occupied France, the men of Flak Regiment 155W could feel it, a sense of dread that no one wanted to admit aloud. The reports from their forward observers no longer read like statistics. They read like obituaries for the Reich's hope. 82% interception, hundreds of missiles lost before reaching English soil, and no explanation that made sense. Colonel Max Wachtel, the man who once believed he was commanding the weapon that would bring Britain to its knees, now found himself defending his reputation against the numbers. In Berlin, the same question echoed through every command hall. How are they doing this? The Reich's scientists had designed the V1 using flawless logic. The flight speed, the altitude, the unpredictable pulse of the jet engine, all of it should have made interception nearly impossible. Their ballistic math was perfect, their confidence unshakable. Yet every day, more flying bombs vanished in midair, consumed by explosions that no German gun, no known radar, and no fighter could possibly cause. It was as if London's defenders had broken the laws of probability themselves. In the conference rooms of the Luftwaffe's research offices, panic disguised itself as professionalism. Charts and graphs covered the walls. Smooth German handwriting noting unexplained loss rates, unknown countermeasure, anomaly in interception data. But behind the numbers was fear. At Peenemünde, the birthplace of Germany's vengeance weapons, engineers who had once celebrated their technological superiority now stared in disbelief at the evidence. Something in the air over Britain was turning German innovation into wreckage. Dr. Robert Lusser, the V1's control system designer, tried to explain the phenomenon in purely mechanical terms. Perhaps, he said, the British have improved their fuse timing methods, but that theory collapsed within days. The British were firing far fewer shells than before, yet destroying more targets. The efficiency was mathematically impossible. The truth, though invisible, was already surrounding them. Millions of tiny radio transmitters sitting in Allied ammunition bunkers, each one ready to perform a miracle. While German scientists struggled to explain what they couldn't see, British gunners didn't even know what they had. The men on the cliffs of southern England simply saw results. The glowing trails of the V1s, once unstoppable streaks of flame, now ended in mid-air fireballs. They called their new shells magic ammunition. They didn't know the name. Proximity fuse. They didn't know that each shell carried a miniature radar system inside it. They only knew that for the first time since the Blitz, they were winning the sky, and with every explosion, London breathed a little easier. By early September, British anti-aircraft batteries were celebrating victories that defied imagination. Shell after shell found its mark. The buzz bombs, as Londoners called them, fell in flames into the English Channel. The nightmare was ending, one invisible signal at a time. Inside the Reich, the search for answers turned desperate. Special teams were formed to analyze missile wreckage and intelligence reports. The problem wasn't sabotage nor poor construction. Every V1 that fell short had functioned perfectly, right until it was torn apart mid-air. Wachtel sent word to Berlin. Enemy artillery effectiveness exceeds theoretical limits. Translation: the impossible had become routine. When scientists at Peenemünde tried to simulate the phenomenon, they couldn't reproduce it. Their test ranges lacked the one thing that made the British defense so deadly: the proximity fuse. The Germans had no idea that across the Atlantic, entire cities were now factories of innovation. In Ohio, at the Crosley plant, the air buzzed with the rhythm of production. 10,000 workers, many of them young women, assembled delicate glass tubes and copper circuits by hand. None of them were told what their work was for. They only knew it was vital. Each fuse was a masterpiece of miniature engineering. A battery, a radio, a switch, and a detonator, all packed into the nose of a 90mm shell. When fired, it became a radar pulse, invisible, precise, lethal. To the workers, it was another day's task. To history, it was the beginning of electronic warfare. The irony was almost poetic. Germany, the land of precision, was losing to a nation that had mastered imperfection. Where the Reich demanded flawless craftsmanship, America built resilience. Where German scientists pursued theoretical perfection, American engineers pursued mass reliability. And in that difference lay the future of warfare, because perfection is fragile. But reliability endures. Each American factory floor became its own front line, where assembly line workers replaced soldiers, and every correctly soldered wire was a silent victory. By late 1944, U.S. factories were producing 22 million proximity fuses, costing over $1 billion in 1940s money. The Crosley Corporation alone accounted for nearly 5 million. At peak production, 1 month of Allied fuse output exceeded the total number of V1 bombs Germany produced during the entire war. And with each day, the gap widened. In Germany, despair was turning into denial. At Flak Regiment 155W's headquarters, officers debated impossible theories. Maybe the British had learned to jam the V1's gyroscopes. Maybe their gunners had superhuman reflexes. Maybe, someone suggested quietly, God himself had taken London's side. No one dared to say the truth, that the Reich's technological arrogance had blinded it. They had believed proximity fuses were impossible. Now, they were dying because of them. When the Allies finally pushed through Normandy and liberated northern France, the launch sites for the V1s fell one by one. The terror that had haunted Britain for months came to an abrupt end. But the V1's failure sent ripples far beyond the battlefield. At the highest levels of the German war machine, the discovery was crushing. For years, Hitler's scientists had promised victory through innovation, rockets, jet fighters, and miracle weapons that would restore the Reich's dominance. Instead, the Reich had been defeated by a weapon no one could see. The proximity fuse had exposed a truth that every German engineer now understood too late. In modern war, industry is strategy. As the Allies advanced, so did the weapon's reputation. In the Pacific, the U.S. Navy had already used proximity fuses to defend ships from kamikaze attacks. Admiral James Forrestal would later write, The proximity fuse has helped blaze the trail to Japan. Without it, our cost in men and ships would have been immeasurably greater. From the skies over Britain to the waves of the Pacific, this small device had rewritten the balance of power. It didn't matter how advanced your missile was if your enemy's shell could think faster than you. Meanwhile, at Peenemünde, a quiet crisis unfolded. The same scientists who had once designed the world's most advanced rockets were now reading reports that shattered their confidence. When Allied intelligence finally revealed the secret after Germany's surrender, those same men were speechless. They were shown actual proximity fuses, glass tubes, copper coils, batteries the size of coins, and told these had survived being fired from artillery at 20,000 times the force of gravity. Dr. Werner von Braun reportedly stared in disbelief, saying this cannot be. The tubes would shatter, but they didn't. They worked. And that was the difference between theory and practice, between precision and production, between what Germany imagined and what America built. In one sense, the proximity fuse was the most democratic weapon of the war. It didn't rely on elite pilots or secret commandos. It depended on ordinary people, machinists, factory girls, radio technicians, and scientists who worked together, each understanding just a fraction of the whole. No single genius could have invented it alone. But a free society could. Dr. Merle Tuve, the physicist who led the project at Johns Hopkins Applied Physics Laboratory, would later reflect, "We succeeded because no one person had to understand everything. We trusted each other. It was a quiet, powerful rebuke to the totalitarian system they fought against, a system that demanded control instead of cooperation." The Germans never caught up. Their own research teams attempted to replicate proximity technology, but the war was already lost. Their electronic industry, crippled by bombing, couldn't match American scale. And when the Allies began their final push into Germany in 1945, the Reich's labs were found filled with half-finished prototypes, ideas that never had the time or the freedom to become real. The proximity fuse had done more than destroy V1s. It had proven that freedom of thought and freedom of collaboration was the most powerful weapon on Earth. When historians look back, they often rank the proximity fuse just below the atomic bomb in terms of wartime importance. The difference? The atomic bomb ended the war. The proximity fuse saved the world that would inherit it. It protected London during its darkest hours, guarded fleets across the Pacific, and proved that intelligence, human or mechanical, could triumph over terror. It didn't roar like a bomber or blaze like a rocket. It whispered in radio waves, unseen, unheard, unstoppable. In Berlin, the scientists who once called themselves masters of modern engineering sat in silence as Allied officers explained what had defeated them. Colonel Wachtel, the commander of the V1 offensive, reportedly said after the war, "We believed our enemies improved their timing devices. We never dreamed of a self-thinking shell." When shown a working model, he simply nodded and said, "We were 10 years behind." The proximity fuse had done what thousands of Allied bombers could not. It had destroyed Germany's confidence in its own genius. By September 1944, the V1 campaign was finished. London was bruised, but unbroken. The skies were clear again. And in Allied command rooms, a quiet pride replaced exhaustion. They had defended a city not through luck, but through logic, not through brute force, but through cooperation, not through magic, but through science made real. By September 1944, the thunder that once echoed across the English Channel had fallen silent. The launch ramps in northern France stood empty, their rails twisted, their fuel drums abandoned in the mud what Hitler had called his vengeance weapon. The miracle that would force Britain to its knees was now nothing more than scrap metal rusting under autumn rain. From his headquarters in Germany, Colonel Max Wachtel stared at the final reports. Out of every 100 V1s launched, fewer than 20 reached London, 82% destroyed in the air, the rest scattered, crashed or failed before ignition. The numbers told the truth that propaganda could not. The V1 campaign, once the pride of German sciencemen, was finished. In the same offices where the first launch had been celebrated, engineers now sat in silence. They had followed every rule of mathematics, every law of aerodynamics, every principle of design they knew. And yet, their perfect machine had been defeated by something they had declared impossible. When the Allies advanced through France, they captured the ruins of those launch sites, concrete bunkers filled with half-assembled missiles, fuel tanks, and charts written in precise German script. But what they discovered inside those papers wasn't power. It was arrogance, the belief that brilliance alone could win a war. Back in London, the atmosphere was completely different. For months, the city had lived under the buzz of the flying bombs, a sound Londoners would never forget, the rising drone that meant death was coming. Now that sound was gone. When the last V1 fell, people stepped out into the streets and simply looked at the sky-clear, quiet, safe. Few of them knew why. Even fewer had any idea that their safety depended on a secret so valuable that its existence was hidden from nearly everyone, including the soldiers who used it. The proximity fuse wasn't just a device, it was a fortress of secrecy built inside a bullet. Only a handful of people in the entire Allied command structure knew how it worked. Production was divided among more than 100 factories. No single worker understood more than a sliver of the process. Every shipment was logged, guarded and tracked. Unexploded shells were recovered within hours to prevent German hands from ever touching. The Allies guarded this technology as carefully as they guarded the atomic bomb, and with good reason. Both were war-ending inventions. In Washington, D.C., the success of the proximity fuse was kept so classified that even generals were briefed only when absolutely necessary. When scientists from Johns Hopkins Applied Physics Laboratory presented their data to the War Department, one officer reportedly asked, "Do you realize this may be the most important invention of the war?" They did, but they couldn't tell anyone. For months after the V1 campaign ended, the secret held. Even as Allied artillery units in Europe begged for the new fuses to use against enemy troops, the answer remained no. If even one shell misfired and landed intact in German territory, the secret would be lost. Thousands of soldiers died waiting for permission that didn't come until December 1944, and when the Battle of the Bulge forced commanders to take the risk. When they finally used proximity-fused shells against German forces, the effect was immediate and devastating. The explosions were perfectly timed above enemy troops, scattering shrapnel with surgical precision. German survivors later said it felt as if the shells could see them. The secret was still safe, but its impact was now undeniable. In Germany, meanwhile, the illusion of technological superiority had shattered. The V1 campaign had drained precious resources, steel, fuel, labor, that the Reich could no longer afford. Tens of thousands of concentration camp prisoners had died in the underground tunnels of Mittelwerk building those missiles. They worked in darkness, starving, surrounded by the echo of engines meant to destroy a city they would never see. The moral contrast between the two sides could not have been starker. On one side, forced labor and death. On the other, voluntary overtime by factory workers who believed in what they were building, even if they didn't know what it was. At Sylvania's Ipswich plant in the United States, more than 5,000 women worked 12-hour shifts assembling the tiny vacuum tubes that made the proximity fuse possible. They didn't ask questions. They trusted the cause. Many discovered only after the war that they had helped save London from annihilation. When those women saw photographs of the bombed neighborhoods their work had protected, many wept. They hadn't built weapons, they had built survival. The proximity fuse had proven something larger than military victory. It showed that freedom of collaboration was a weapon of its own. Dr. Merle Tuve, the scientist who led the project, explained it best after the war. "We won because our society allows cooperation between scientists, soldiers, and workers." That single sentence described the real battle of World War II. Germany had genius but no trust. Its scientists worked in isolation. Its workers in chains. The Allies built networks, not monuments, systems of minds and machines that multiplied one another's strength. The proximity fuse was the ultimate expression of that difference. After Germany's defeat, Allied investigators interrogated captured engineers and officers about their understanding of the new weapon. The answers revealed just how blind the Reich had been. They had noticed the impossible accuracy. They had even recovered fragments of Allied shells, but they had never imagined a self-triggering electronic device small enough to fit inside an artillery fuse, shown an actual proximity fuse after the war. Many German scientists simply refused to believe it had survived a gun's firing. One physicist reportedly held the device in his hands and muttered, 10 years. We would have needed 10 years. For them, the realization was humiliating. They had poured their talent into rockets and jet planes, while their enemy had mastered the invisible. In the Allied nations, news of the invention finally became public in September 1945. The War Department statement began with the words, "One of the most important weapons developed during this war, surpassed in effectiveness only by the atomic bomb." For most civilians, it was the first time they had even heard the term proximity fuse. Newspapers printed photographs of the small glass and metal device, marveling that such a tiny object had saved entire cities. Readers stared, amazed that the war's second greatest secret had been hiding inside a shell all along. Historians would later call it the fuse that won the skies. But its legacy went far beyond the battlefield. In the years that followed, the technology behind the proximity fuse evolved into the heart of modern electronics. Radar altimeters, guided missiles, early computers. The same miniature tubes that once destroyed V1s became the ancestors of everything from jet navigation systems to space probes. It was the first time in history that a weapon had accelerated, the birth of a new scientific age, and it had all begun with a single question in a quiet American laboratory. Can a shell know when to explode? That question changed the world. Yet the human side of the story mattered even more. For every scientist whose name appeared in history books, there were thousands of anonymous workers who never received credit. They soldered wires, tested circuits, and packed crates. They were teenagers, mothers, veterans, refugees, the unsung army of industrial democracy. While German engineers worked under the eye of fear, these people worked under the promise of freedom. They were told, do your job well, and you'll save lives. And they did. Their labor turned theory into reality, and their faith turned machinery into meaning. When Allied scientists later met their German counterparts after the war, the difference between the two worlds became painfully clear. The Germans had been forced to work for power. The Allies had worked for purpose. The proximity fuse stood at that crossroads, a tiny object that represented not just technological superiority, but moral clarity. It had been born from curiosity, not conquest. Its goal was defense, not domination. And its success proved that in the modern world, victory would belong not to those who shouted loudest, but to those who listened, to science, to cooperation, to the quiet rhythm of progress. By the end of 1945, as the war's dust settled, former German scientists finally saw what had defeated them. They examined captured Allied documents, production logs, and circuit diagrams. They realized the scale. 22 million fuses produced, $1 billion invested, 80,000 workers employed. They understood then that the war had never truly been between armies. It had been between industries, between the Reich's perfection and America's abundance, between centralized control and collaborative creativity, between fear and trust. And in that contest, the outcome had been decided long before the first V1 took flight. The proximity fuse didn't end the war, but it defined the world that followed. It taught future generations that technology is only as powerful as the system that builds it, that innovation without cooperation is just noise. It also left behind a quieter, more human lesson, that somewhere in a factory or a lab, ordinary people can do extraordinary things, even if history forgets their names. War often ends not with an explosion, but with a silence that feels impossible. When the guns finally quieted in 1945, that silence carried the sound of invisible victories, the kind that happen in laboratories, on factory floors, and inside the hearts of people who will never wear medals. The proximity fuse was one of those victories. It never had a parade. It never had a face, yet it had saved a city, reshaped science, and quietly redefined what it meant to win a war. In the ruins of Europe, German scientists stood before Allied officers and saw the device that had undone their vengeance weapons. A fuse small enough to fit in the palm of a hand, glass tubes, copper coils, a tiny radio brain that could sense distance and decide the perfect moment to explode. They held it, speechless. All the equations, all the years of research, all the faith in mechanical perfection, defeated by a handful of mass-produced miracles. Dr. Ernst Steinhoff, one of Peenemunde's senior engineers, later confessed that when he first examined a captured fuse, he felt both awe and despair. It was so simple, he said quietly, so simple, and we never thought of it. That simplicity was the point. Where the Reich had chased greatness through complexity, the Allies had found greatness through clarity, through the discipline of designing for the ordinary. It was not a single genius that defeated Germany, but thousands of nameless collaborators who believed that if they worked together, anything was possible. After the war, the laboratories that had built proximity fuses didn't close their doors. They evolved. Their scientists moved from building shells to building satellites, the same mathematical minds that calculated shell trajectories soon plotted orbits to the moon. The same miniature circuits that once sensed bombers became the ancestors of radar altimeters and guidance computers. What had begun as a tool of destruction had become the seed of exploration. Without the proximity fuse, there would be no guided missile, no modern air defense system, no reliable radar altimeter in passenger planes. Its DNA lives in every spacecraft that lands softly, every jet that measures its altitude by radio, every device that senses the world around it. The fuse that saved. London also helped launch humanity into space. But the most extraordinary legacy wasn't technological, it was human. The proximity fuse proved that democracy could build weapons of precision not through fear, but through faith. Faith that free minds left to cooperate could outthink tyranny. Faith that creativity grows when people are trusted, not terrorized. In underground tunnels across Germany, slaves had built the V1, starving, dying, forced to craft the weapon meant to crush another people's hope. In sunlit American factories, ordinary citizens had built the proximity fuse, singing to radio music, working long hours, believing that what they made might end the nightmare. One side produced despair, the other, determination. That moral divide shaped the century to come. When Allied commanders finally revealed the secret in late 1945, newspapers called it the brain that beat the bomb. For months, the world marveled at the idea that such tiny electronics could decide life and death with perfect timing. But for the scientists who had lived with the secret, the pride was tempered with humility. Dr. Merle Tuve, who led the development, refused to call it a miracle. It was not magic, he said. It was cooperation, discipline, and respect for detail. Those words echoed far beyond the lab. They became a philosophy. That progress comes not from a single spark of genius, but from thousands of steady hands holding the line together. In Germany, that lesson would eventually rebuild an entire nation. The engineers who had once worked on weapons began designing for peace. Cars, machines, tools. They studied Allied production methods and saw the power of simplicity. They learned that reliability is not the enemy of greatness, it is greatness. Across the Atlantic, American scientists took the same spirit into the atomic age, creating networks of research and production that would give rise to Silicon Valley itself. Every transistor, every microchip, every digital sensor carries the ghost of that first miniature circuit that survived the shock of being fired from a gun. In a way, every smartphone on Earth carries a whisper from 1944, proof that small things made by many hands can change everything. Imagine for a moment the night sky over London in those desperate months of 1944, the sound of sirens, the throb of engines, the dread every time the buzzing stopped, that awful pause before impact. Now imagine the first night the sound didn't come, when the city slept, through dawn without a single explosion, when mothers opened their windows and heard only birds. That silence was bought by science, not for conquest, but for protection. A silence earned by millions of invisible acts of faith. Every worker who tightened a screw, every engineer who checked a circuit, every soldier who loaded a shell, all of them built that silence together. The proximity fuse changed warfare, but it also changed humanity's relationship with technology. It taught us that intelligence, whether mechanical or human, carries responsibility. That knowledge must serve life, not worship power. It warned the world that innovation without ethics is only half a victory, because the same mastery that made shells think would soon make bombs think. Rockets think, and eventually computers think. The story of the fuse is the story of us learning what to do with that power. Decades later, veterans who had served in those coastal batteries visited museums where preserved V1s hung from ceilings. Children stared up at them, reading captions about flying bombs. Few noticed the small glass cylinder displayed beside them, a proximity fuse, dusty, silent, forgotten, but the veterans noticed. They would point to it and smile. "That little thing," one old gunner said softly, "that's what saved London." And perhaps that's the most moving truth of all. The heroes of this story were never the generals or the politicians. They were the scientists, the technicians, the workers, the people who built something no one could see. Yet everyone depended on. They didn't build it for glory. They built it because they believed that progress, when used wisely, could protect instead of destroy. That belief still matters, because even now, in a world full of new machines and new fears, we face the same question they did. Will our inventions make us safer, or will they control us? The answer depends on what kind of world we choose to build. So, if this story moved you, if it made you see that history isn't just about battles, but about ideas, courage, and cooperation, then don't let it end here. Take a second right now. Tell us in the comments where you're watching from. Tap that unsubscribe button and join our community of people who keep forgotten stories alive, because every week, we bring you the hidden chapters of history, the inventions, the choices, and the human hearts that shaped our world. Share this video with someone who loves history, someone who believes that even the smallest things can change everything, because they did. The proximity fuse, the tiny device that no one saw coming, turned the sky from a weapon into a shield, and in doing so, it proved something timeless, that the real power of humanity isn't destruction, it's creation.